So we're going to make a setup where we have the center of mass of the system outside the system itself. We're going to take a fork and a spoon, and we're going to attach them together like this. So looking at the distribution of mass, we have some at the top and some at the bottom. So our center of mass will be somewhere between the top and the bottom in this area here, right? Then right and left, they're about equally weighted. So our center of mass will be in between all of these things, right around here. So what we're going to do is we're going to balance these. And the best way to create a stable balance point is to put the center of mass below a pivot. So I'm going to create this pivot here, and the center of mass is below this pivot. I'm going to add this to the edge of my mason jar. Good. I'm going to move the jar to the edge of the table so that the spoon is not touching the table. Okay, let me show you what I got. So now what we can do is we can remove any extra mass on our toothpick, because that's not part of the stability of our system, since the center of mass is actually below the pivot point where the toothpick hits the glass, and so we can remove the toothpick on the edges. Let me bring it in for you. So the pressure puts the toothpick fire out. So over here, you have no toothpick, and the fork and the spoon are just balancing stably on the jar. This is an example of center of mass and how we can use center of mass as a balance point, and how you can make a stable or unstable equilibrium. Let me just interject here to show you what a non-stable equilibrium will look like. So you know that your center of mass is somewhere around here, right? And if you try to balance with your center of mass above the pivot point, it's not going to be very easy. And notice the wide base I'm using my finger, right, instead of the toothpick. So I guess I've given you a couple good examples of the fact that that is not very stable compared to the stability when the center of mass is below. So take the center of mass and put it below the pivot, much more stable. Very challenging to get that to balance with the center of mass above the pivot point. Any variation in the position of the fork and the spoon will make it fall. So here you're seeing a very stable equilibrium as the center of mass is below the pivot point of this system. You can certainly try this at home.